Quiz Prep, Chapter 7.4 and 7.5. Hello, and welcome back to Quiz Prep. Of course, we're moving on to Chapter 7.4 through 7.5 Quiz Prep, but this is actually the last in our sequel, the Chapter 7 sequel, or a series, right, where we're focusing on Matthew Gitlin and his colleagues and how they studied these dialysis patients, right? So, as you can see on the screen here, we're still going for their Charlson Comorbidity Index. We're using the same mu of 4.3 and 2.5. Only now we're going to get into questions that not just involve drawing one X from this population, but drawing multiple X's, like here's 9 X's, people. I guess you shouldn't really call them X's. It's very disrespectful to patients. But don't tell them I said that. Just imagine these 9, because they're experimental units in this case, these 9 X's, these 9 patients. What happens if you get 9? Well, you have 9 X's. I mean, how are you going to fit that in an equation? Well, you have to make a mean. And so what happens when you have to make a mean or an X bar? Then you have these new equations. So that's what's new here. So without further ado, let's get started. Okay, we're going to jump right into question 1, but before I actually do that, I wanted you to notice this slide here. Over here, we have our old friend. Oh, black is such an ugly color. Let's use, I mean, it's appropriate, but we already have too much black. Here, we have our old friend, the z-score formula, just in case we need it. But we have something new here, and this is, I know it's kind of upsetting. It's been photoshopped. This is not a real picture. Okay, I photoshopped this where I use paint. You'll notice this is an adulterated version of what's on the left side. So let's analyze what's the difference, okay? The first change that occurred is you'll notice this bar is on top of the X. Well, what does that mean? What it means is if you get multiple X's or more than one person from the group, you have to make a mean. And it's a sample mean, right? X bar is a sample mean. So that's what you put in this equation if you get more than one person, and that's what you're looking for. But then you also have to worry about the bottom of the equation. Over on the left side, you just have the population standard deviation, but on the right side, you have this population standard deviation divided by the square root of n. And actually, you have to do this part before you complete the equation. You have to do that part separately and then do the division. And so you're like, well, what's the square root of n? Well, they always tell you the n, right? So what would the n be over on this side? What's the n over here? Well, it's 1, right? There's only one person. There's one x, okay? But when you have an x bar, like over here, they'll have to tell you the n in the question. You won't just automatically know, okay? And also, I just want to tell you, technically, if we did the square root of n over here, we'd be doing the square root of 1, which is 1. So it's not like we even totally ignored the square root of n over on the left side. We did it. It's just technically it didn't change anything. So it's just now when you bring in more x's, you just can't get away from having to honor this. And so then what I do in this quiz prep is we sort of walk through different scenarios and you see what I mean. So we start with the easy scenario that we actually are familiar with. What is the probability that one chronic dialysis patient will have a Charlson score greater than 5? So this is like one patient, so we get to use this simpler equation. But again, we have to go through all our stuff. So draw the picture, right? Charlson, right? Middle. And this is going to be 4.3, okay? And then what's x? X equals 5. X is in the question. Okay, we already decided we're using the left equation. Where's 5? It's up here somewhere. And what are we looking for? Well, let's go to our favorite color, orange. We're looking for probability. So we got to do some work, right? So we're going to go to purple. We're going to do z. And we know this is 0, and we don't know what that is yet. And we need a z to get a probability, so we might as well go and start doing our work. So we can use that formula. So remember the formula, that formula. x minus mu. We're using the left side because we're doing the simple one first. So how are we going to get our z? Let's fill in the x. That's 5 minus 4.3 divided by 2.5. So this is our z. And I did this already. I always try to remember to do this before I call you up on the phone on the YouTube. All right, so let's see here. So I did that, and what did I get? I got this z that equaled 0.28. Now remember my warnings before. That z looks an awful lot like a p, like a probability, but it's not. Okay, so don't get confused. So just sort of to go through the exercise again. So we're looking for 0.28, and this is the negative side of the z2. 0.2, here's the 0.2, go over to A column, and we get 6103. Okay, so don't forget that. We're going to put it here. I'm going to put it in orange. PR equals 0.6103. Now, remember we were looking for, oh, I'm sorry, I forgot to color it in. We were looking for greater than 5, right? So this is a little piece. And what do you think we got out of this? That's going to be like 61. That's a big piece. That's bigger than 50%. So we're going to have to do the 1 minus thing. So we'll do 1.000 minus 0.6103. And then if you do that, you get 0.3897. And that's your answer. Okay. Now, it's important to probably save all of these answers. Save this z that you get, save these different p's. And when I say save, I mean when you're taking quiz prep and also when you're taking the real quiz, have some scratch paper and neatly put all this stuff down. Why am I saying that? Because I invented the quiz, and if you want to get through it fast, I try to get you to recycle these numbers. So I'll be asking future questions on the quiz in the quiz prep that use these same things, like a Charleston score of greater than 5 when you're dealing with one patient. Okay, and I'm just giving you this hint because I just don't want you to be overwhelmed by this quiz. Okay, so now let's move on to question 2. Okay, now we're going to move ahead and do question 2, which is going to ask about a sample of 9 patients instead of just one. So what is the probability that a sample of 9, here we go, chronic dialysis patients, will have a sample mean, now we're on this side, Charleston score of greater than 5. I kept the X the same. Okay, and so I kept this number the same here. Now it's an X bar. So what are we going to do? Well, always just start with the darn picture. You know, it's a good way to start everything. So we say ch, and we say 4.3, and we say 5. And I forgot to do this last time. We got to color in the big part. The same old thing is going on, right? It's just that now we're using this equation to get z. So it's going to be, I'm still going to have to write z here, and I'm still going to have to go 0 here. And there's going to be an answer here, but it's just not going to be the same as the last question because we got these 9 patients instead of 1. So so I'm going to rewrite our z equation, just honoring the fact we're using the one on the right side. So z equals x bar minus mu, right? And that's, here is the population standard deviations divided by the square root of n. And I'm going to put that in parentheses. So you're supposed to do that first. So here's the trick question. What is n? Right? Because we're used to this otherwise. Well, and what is x bar? Well, in this equation, we're going to use, since we're using this side, we're going to say x bar equals the x in the equation. Well, now it's an x bar. It's 5, right? And then n equals, what does n equal? Well, it's the number of patients we have got over here, right? So here we have 9. Now we're really ready to fill this in. Okay, so we're going to do z equals, I'm just going to fill it in down here. I'll just draw a little line here. So we have 5 minus 4.3 divided by, I'll do the parentheses so you don't get confused, 2.5 divided by the square root of 9. Okay, and you have to do this bottom part first, and then, do this part first here, and then divide this by whatever you get down there. And you'll notice I have a proclivity for fixed squares, so you don't even need your calculator to do square root of 9. But if you do all that, you'll get a z. You'll definitely get a z. And what you'll do is you'll get the z of 0.88. Okay, now I just want to stop here and say it's really kind of hard to do things like this on your calculator. So what I like to do is I like to calculate just the bottom first, just this part first, right? So in other words, I'm the kind of person that would do this part first and then rewrite the whole equation. So why would I do that? Because I really do statistics a lot, and they have a name for this. You know how like this over here is this population standard deviation? Well, this one right here on the right side is called the population standard error. Remember how in statistics some errors are actually bad and some are not? This is one that's not bad. It's just called the standard error when you put the square root of n under it. So what my habit is I calculate the standard error first, and then I do the rest of the equation just using the standard error instead of the population standard deviation. So when I did this problem, the first thing I did was I just did this little part down here. Let's use blue. I just did the standard error. And by the way, I often say this is SE. I don't know what your book uses, but that's SE, for standard error. But I did the standard error all by myself, and I got 0.8. And so that when I went to do this part, I just didn't even bother with this huge thing. I just put 0.8 in for it, and then I did the whole thing. You get the same answer. I mean, maybe I'm making a big deal about this whole thing, but in any case, I just wanted to point out the whole standard error thing, in that it might be better to do these things in 2 steps. Okay, well, getting back to what we're actually working on is we were looking for a probability, and in order to get to that we needed a z-score, and we just got that. So that we're not done with the problem yet. I just went on a tangent there about the standard error. So we have the z-score of 0.88. What do you do with the z-score? Yeah, look it up. That doesn't change just because you have a bunch of n. So let's hear 0.88. Where's that going to be? Here's 8. 0.88. So we get, what is this? 8106.8106. Where do we go here? So that's going to be an orange probability equals 0.8106. So what do we do now? We compare that back to our picture. So we were looking for this little tiny piece, and 81%, that's a little on the big side. I don't think we're looking for that one. So we got to do the post-processing step of minusing it from here, 0.8106, and figuring out what the little piece is. Oh, okay, here we do. Here we go. The little piece is 0.1894. Okay, so there you go. That is the answer to question 2. Now again, remember what I told you. Keep all of these around. Keep that probability, both of the probabilities you found, this little piece, the big piece. Keep that z-score around because you're going to probably need to recycle it later. Okay, now we make it to question 3, and what's the difference? What's new is we just really have a bigger group, right? 25 chronic dialysis patients. You got the same X, this greater than 5 thing, no surprises, but now we can even just start by going n equals 25, right? And what is our X bar? It's always what's in the question. If you get more than one, it's X bar, and that's 5. Let's just power through this. So this is our Charlson, Remember what we're doing, we're drawing the picture, and we know, whoops, I did that wrong. This is 4, I'm trying to skip ahead too quickly. So this is 4.3, and this is 5, coloring the part you want. It's greater than, I'm not trying to trick you. Okay, now what's our z? Z, well, we know this is going to be 0, but we don't know this one yet. And that's the whole point. So we're going to do, only this time what I'm going to do is do the standard error first, just for fun. So here's the standard error, right? Remember that? That's this guy. Okay. Divided by square root of n, which is the same in our case as 2.5 divided by the square root. And you have to do the square root thing first of 25. Oh, perfect square. So we could probably maybe even do this in our head, but I can't. So this would equal 0.5. So that's what our standard error equals. In fact, let's throw it up here. SE equals 0.5. Why not? Okay. Because then you can kind of have a little more real estate to move around and so I got that. That really wasn't that hard, was it? No. Absolutely not. All right, so let's go back. What are we calculating z? So let's go grab our purple again. So now I'm just going to say z equals x bar minus mu over, let's just say SE. Make our lives easier. Okay? And then when we fill it in, it's a little clearer. So we're going to do 5 minus 4.3 divided by our SE up here, right? And that's 0.5. And what do we get now? And of course, we're looking at z, and we're getting 1.4. That's kind of a biggie. All right, so that's a little bigger. So let's look up that one. So 1.4 is over here. Oh, here's 1.4. And notice how it's just like plain old 1.4. I mean, if you did 1.40, like what do? Well, actually, you just go over the first one. See this O? Okay, so it's 1.40 technically, and so you get 0.9192. So let's go back here. Oops, I should have changed here. So PR equals 9192. Okay. Time for the reality check. Remember, we go and we go, almost 92%. That can't be right. The little bees. So you got to do the post processing. Let's go do it. 1 minus 9192. And what's that little thing we get at the bottom? It's really little, 0.0808. And so that is our probability here. It's 0.0808. So you see, it keeps kind of getting smaller because the more you involve more people, the probability that it's going to be way up here, that a whole mean is. Like if you just have one person, yeah, you might get lucky and get somebody up there. But if you get 25 people, you're really going to have to get some odd people to get their whole mean to be up there. So that's why this probability keeps going down. I mean, that's essentially why. All right, well, let's move on. Okay, now we get to the more involved questions. We're starting with question 4, and you'll notice that I sneakily put the answers from our previous inquiries in quiz prep for this chapter up here on the right, just so we can refer to them and so we don't have to go redo them. Okay, let's focus on the question. What is the probability, again, we're looking up stuff in the Z table, that one chronic dialysis patient, so we're over here on this side with the simpler equation, that one chronic dialysis patient will have a Charlson score between 4 and 5. So let's draw the picture for Charlson, 4.3 for the mu. And like we talked about before, we have an x1 and an x2. So x1 is 4 and the x2 equals 5. And that's why it's really nice that we kept this around, because we already have information about x2. So we're going to just, so here's 4, here's x1, and here's 5, which is x2, okay? And we're not going to have to do much with 5 because we already have the answers. Okay, so we're looking for the probability of what? Well, that it's between 4 and 5, so we're actually going to color in this middle part. And yeah, you remember this from before? So what's our strategy? Our strategy, I'll use green here, is to calculate the probability of that, the little piece above 5, which we already have actually. Uh, let's see here, the probability for the small piece, yeah, that's actually over here, right? So we want to calculate that. The thing we don't have yet is this small piece for the 4. And then the idea is we're going to do 1.0 minus probability for less than 4. You know, this one over here. That's not really next, but that section. And then we'll minus the probability greater than 5, which is this little part over here, right? I mean, a little zigzag. And then whatever's left over is going to be what's in the middle, right? So that I'm just giving you the game plan because, you know, it's been a while. All right, so now what's the next thing we have to do? We're focusing on x1. Well, we have to get that probability. You know, what we don't have, you know, like I was pointing out, is we don't have that. So we got to get that probability. So how do you get that? You go into Z land. So we're going to set up our Z. Hello, Z. We have this 0 here. Actually, see the Z is 28. We can actually fill that in for x2, believe it or not. See how nice I was? I'm that way on the quiz too. So we've got that Z, but we do not have that one. And remember, we're on the left side because we only have like one patient. Nobody was willing to be in our study. All right. So so we're going to use Z equals x minus mu over standard deviation, which is the same then as what's x? X, we're using this x because we don't know it. 4 minus 4.3, great, this is going to be negative over 2.5. And what do we get out of that? Oh, we get negative, this is a z now, even though it's little, negative 0.12. Okay. Time to go to the table. Okay, so negative 0.12. So we're already in the wrong place. Negative 0.1, and then we've got to go to the 2. I think this is the 2 column because remember there's a 0 column. Here we go. Negative 0.12. So that should be this 4522. And yeah, that's pretty good. Okay, so 0.4522. Let's go back here. Let's get out here. So this is PR equals 0.4522. So do we want that, right? And I think the answer is actually yeah, we do want that one. Because if you do the little doot thing that I like to do, you get 45%, which seems like a lot, but it's actually less than 50%, right? And so we actually we're getting remember we were looking for either we're getting this or we're getting this because we were just concentrating on the 4. And we got 45%, so we must have gotten this side, which is what we wanted, right? So now I'm going to just fill this, remind us that the for x equals 4, right? The PR for a small piece is 0.4522. So what do we do now? Well, we have this little piece here, which is this one. And we have this little piece here, which is this one. And we're going to go back to our game plan. Remember, we're going to do 1 minus this one, and then minus again this one. And if you actually do that whole thing, then you're going to end up with just a little bit left, 0.1581. This is not actually very big. So if you just in your head do that's like almost 16%. That's pretty small. Why? Because this was already a lot, almost 40. This was over 40. So there really wasn't much left. But that's the answer to question 4. Now we're going to go through 5 and 6, and they're going to go really similarly. The trick is we're going to use the standard error on the bottom of the equation, and we're going to use x bar, which is kind of like x, on the top of the equation. We're going to use the formula on the right, and otherwise it's going to go very similarly. Okay, now we're moving on to question 5. So what is the probability that a sample of nine chronic dialysis patients will have a mean Charlson score between 4 and 5? So this is just like the last question. Well, we have 9 people now, so we're looking at this side, right? And as you can see, I copied in the information we learned when you have an x bar of 5 and an n of 9 from the earlier questions, so we don't have to do that. So what do? Well, I always start with a picture. So here's Charlson, 4.3. We know we're going for a 4 over here. We're going for a 5 over here. We want a color in the middle. And just to remember, our game plan is we're going to do like this thing where we do 1.0000 minus whatever this piece is. So that's like a less than 4. That's a probability less than 4. And then we're going to minus the probability of greater than 5. So that's probability, this is a p here, greater than 5. And then we'll get whatever's left is going to be that middle red part, right? So just to remind you, we actually have one piece of those probabilities. We have this one here, right? Because that's actually this one up here. So we don't have to do it. So we do have to do the 4 one. See, isn't this great that we recycle? So how are we going to do the 4 one? Well, now, right now we're going to be looking for this probability. And so what do we need? Well, let's go. Welcome to Z-land. We need this Z here, right? We have 0 here. We need that Z there. And we got to use this side of the equation because we have n's involved. So we've got Z equals x bar minus mu over, now this is the standard error. I just feel compelled to put these parentheses so you don't forget to do this whole thing first. And now I'm going to fill that in with the numbers that belong there, which is, so we're going to do 4 for our x. This is 4 minus 4.3 divided by, here's a little parentheses, 2.5 divided by the square root of 9. And if you are lucky enough to actually get through that equation, then you're going to get a, for 4, you're going to get a z, we're still in z land, z of 0.36, negative 0.36, okay, because it's on the left side. So now we need the probability of that. So let's look it up. So that's what you do with z-score. So negative 0.36, negative 0.36. So here's negative 0.3. Now I gotta look at the top where the 6 column is. Okay, so that's 4 from the right. So negative 3. So here it is, 1, 2, 3, 4. So we get 0.3594. Let's write this down before I forget. 0.3594. I even wrote it right this time. How about that? Okay, some reality check time. Is this, we go and we get almost 36 if we do that. Is that the piece we're looking for? Well, we'll go over here. Yeah, we wanted this little tiny piece, and I mean, it's not really tiny, but 36 is less than 50%, so that's what we want. So now we have this and we have this, and if we subtract 1 minus those things, so we'll go 1 minus 0.1894, also minus 3594. Then we've trapped this middle probability in here, and we get the answer of 0.4512. Okay, and then so if we do that, then we can go forward and answer the question. So that's the probability. Okay, so we have one more like this. Guess what? It's the one with the n equals 25. So let's see if we can do that one just as well as we did this one. Okay, things should go pretty fast now. We're getting used to this, right? So we're looking again for the probability. This time we're looking at a sample of n equals 25, right? Again, I put our old answers up here, and then we can just get started. So we're going to draw the picture. Charleston here. Here we go. We got 4 down here. We got 5 up here. We're going to look for, we already have this piece. It's over here. So we're not going to deal with that. And we're going to look for this piece because we're trying to find this out in the middle. We need to do our z's. So z, already here, this is a z of 0. And we figured out a z for 5 before, but we don't know the z here. So let's go next. Z equals x bar, which is going to be, well, we'll just draw it here, x bar. Why did I do this? Minus mu over, and then the standard error. Okay, what does that translate to in this question? 5 minus 4.3 divided by, here's parentheses, 2.5 over the square root of 25. Okay, fast forward, if you do that equation right, then you're going to get a z of negative 0.60. Okay, what do? Look it up. 0.60, negative 0.60, negative 0.6. And remember, this first column is O. See that? Or it's supposed to be 0. Once somebody yelled at me, I said O and it's supposed to be 0. So, sorry. Negative 0.60 is this 2743. So let's remember that. 2743, 2743. 0.2743. That's our probability here at 4. And again, you know, 27%. So we got what we wanted over here. You know, we got our little one. So so now what are we going to do to get this middle part? We're going to do 1. Oh, that wasn't very pretty. 1 minus 0.2743, what we just got, minus this one, 0.0808. And if you do that, you'll get the probability of the middle, and that's, oh, I guess I better write it down here, I'm running out of room, is 0.6449. So there you go. You made it through question 6. Okay, so finally the last question, which is kind of a logic question. And I put it here with the formulas because I wanted you to think about it. So why is it that the probability of getting a sample with the sample mean near the population mean always increases as you sample more individuals? So why is it that when you've got a situation like this, you know, where you have a Charleston and your mean somewhere at 4.3, and you're asking about this middle part, that's what this is. Why is it that the more people you grab, the bigger your probability you're going to find somebody in there, or you're going to find the mean to be in there, this x bar? In other words, if you look back at our answers for like questions 4, 5, and 6, the answer to question 4, where we just had one person, was 0.1581, which is like kind of small. But then when we went back to question 5, that's where we got 9 people, and I should say equals. And that went up a lot, like 4, 5, 1, 2. So if you grab 9 people, the chances, the probability that their X bar is between 4 and 5 goes way up. And it goes up again if you get 25 people, which we did in question 6, and that's 6, 4, 4, 9. Yeah, why does it keep going up? Um, well, I mean that there it's sort of logical, but one answer that you can make is that over here, as remember that standard error, you'll notice that this thing downstairs is the square root of n, and that no matter, even though you're taking the square root, if you make that n bigger and bigger, it basically makes the top of this it makes this whole standard error smaller. And the smaller your standard error, the more likely, if this is your middle part, that you're going to end up in the middle part. So I'm just going to go over the answers to the questions, because I gave you this as multiple choice, so you don't have to think too hard. But you do have to know what you're talking about, because question A is the bigger the standard deviation, the smaller the n. Well, this is the standard deviation, and n is like whatever you pick. So that first one is just totally nonsense, and I hope you would know that because they're independent. Then you know the answer must be B, right? Because I was just talking about this. The bigger the n, the bigger this n, the smaller the standard error, which is this thing. So this is the answer. But I just want to point out the dumb answers, which is questions, or the answer C. The bigger the mean, the smaller the variance. This is the mean, or this is a sample mean, right? And then the population standard deviation is this, and if you take that to, exponentiate that, like it to itself, it times itself, then you get the variance. Well, they don't have anything to do with each other, so this is a dumb answer too. And then finally, the bigger the variance, the smaller the standard deviation. Well, that's dumb too, because the bigger the variance, you take the square root, you get the standard deviation. The bigger the standard deviation, it's the opposite. So that's dumb too. So now, congratulations, you made it through. This was also kind of tough, just like the last one. But this is the end of chapter 7. This video specifically the end of chapter 7.4, 7.5 quiz prep. So in this particular quiz prep, we folded in the idea of looking at standard error and x bar, not just x, and standard deviation. And so now you take this test, and then we'll be done with chapter 7. You've been really good sports. Thank you very much, and good luck.